Welcome to the Sysadmin Show, the podcast that explains everything sysadmins do and the technology they work with. I'm your host, Dustin Raybrick, here to give a jumpstart to your IT career. Today's episode is In the Lab, Python versus Bash with Ken Youens Clark. Well, how you doing? It's been a long couple of weeks for me as I prepare for the SysP test, and I actually took it last Saturday and I got the provisional passing score. Really excited about that. Glad to have that behind me, the weight off of me. It's really been kind of hanging over me. I don't do well with tests, and this was my first certification. Plan on going into more detail on that in a dedicated mini episode. And but just wanted to let you know that I've passed, and I'm hoping to go through the phase 2 pretty soon to actually get the cert in my hands. So today's episode is another one that's kind of a partnership with Manning Publications. I've been staying in touch with them since I did a show about PowerShell with them a while ago, and last show was actually about another Python author that they have. And so this is one of the books that we identified that would really be a decent fit for the show. And this is a little bit different take on the same topic of Python, something that I've been interested in lately. And this is an In the Lab episode, which is pretty cool. So Manning Publications is sponsoring this episode, and I really appreciate their help supporting the show. They have provided me with a 40% discount code to share with you. Any product, any format, no expiration. And that is PODSYS19, PODSYS 19. And we also have free 5 ebook codes available for this episode. So anybody who wants to get a chance at one of those, email me, dustin@sysadminshow.com. The first 5 emails asking for one of those will each get one. Visit manning.com to browse their huge selection of technical books. And I really appreciate Manning's support of the show. So like I said, this is going to be an In the Lab episode. So there will actually be a YouTube video component of this, as I've done with a lot of my previous In the Lab episodes. And this is a very technical one. We're really going to get into some code, and you can definitely follow along with just the audio. That's going to work fine. But if you want to see what's going on and maybe try what's going on your own lab setup, then I highly recommend take a look at the show notes. I'll have a link to the YouTube video there, and it will be the identical audio stream. With that being said, we're going to cut over to the interview with Ken, and then I'll have a few thoughts at the end of the show. I am here with Ken Youens Clark. He is a senior level programmer with over 23 years of experience developing software in industry and research environments. Hi, Ken. How you doing?
Hi, very good. Thank you for having me on.
Well, I really appreciate you taking the time. And as my knowledge through Python continues to kind of spark and grow, I'm really interested in talking to people who are in the industry and working with Python on a regular basis.
Well, I'm definitely happy to share what I've learned about Python.
Cool. And this is going to be a little bit of a different episode than a typical podcast, because we are also recording video, which will be available on the YouTube channel. So I'm going to consider this kind of a in the lab session where it's a little bit more relaxed, and we actually do a little bit of showing of what we're doing, not only just talking about it.
Look forward to that.
Cool. So I see here on your LinkedIn page, you have yourself labeled as a bioinformatics hacker. Can you just explain to us what that means to you?
Yeah, so bioinformatics is a field that's only been around for 20, 25 years or so. It's really the intersection of computer science and biology. So there was a time up through the 90s where biology was really pretty much a bench science, a wet science, where you worked at a microscope and you had these experiments with pipettes, and your data would fit easily into an Excel spreadsheet. And then with the advent of genome sequencing, we started getting much more data, and now we're just absolutely flooded in data. The cost of sequencing and the amount of data that we can produce is outpacing Moore's law. So biology has really become a data science, and so we have to apply all best practices from computer science to understand what the data that we're producing.
And are you familiar with the what's the name of that new project? Folding at Home, I believe is what it's called.
Oh yeah, yeah, that's a really cool project where they are outsourcing basically protein folding algorithms. So people can run that on their machines at home. Yeah, it's really cool.
I've heard that's quickly becoming a very compute intense, or that the people who are offering up their machines, kind of like SETI at home used to be,
Yeah,
it's actually quite a lot of computing power available to it now. So many people are offering up their machines.
that's fantastic. It's an enormously complex problem.
Cool. Well, I'd like to hear a little bit about how you got your start in technology and kind of to understand where you came from and how you got to where you are today.
Oh yeah, it's a really pretty much a series of just bumbling around and making a lot of mistakes over the years. So I went to college in 1990s when I started and thought I was going to be well, I was a music major for a couple of years. I was playing the drum set. I was a jazz studies major. Decided I wasn't going to become a musician. Changed my major a few times. Really had no idea what I was doing. I got out with an English degree with a minor in music, which prepared me to do really just nothing. But in my first job, which was essentially being an office boy, answering literally fax machines back then. This was around 95. And, answering the phones and taking orders. Out of all places, a company that produced synthetic DNA and peptides for molecular biology research. None of this I understood. But I was drawn to the computers, and so I started working with kind of the advertising and marketing side of that because my parents did that. And so I was drawn to that, and I started making like the mailing list, and I started using an Access database to deduplicate the addresses, and I used software to lay out the catalogs. I created the company's first website using Notepad to hand code all the HTML, and learned how to use PuTTY to FTP the files over to the web server. And so it just kind of got started, but that still wasn't programming. So my next job, I actually got hired as a technical writer to write a software manual for a piece of software that this guy named Eric Thorson had written. And I showed a lot of promise and a lot of interest, and he asked if I would be interested in learning Visual Basic to support that program. And I just leapt at the chance. I just kind of felt in my bones that I wanted to be doing something with computers, and programming really seemed like the thing that was drawing me. So after about a year and a half with him, it's scary to say, but I had enough chops to go out and become a consultant. And I was working in Delphi. And then around 98, I just felt like the internet was going to be where things were moving. And I was really getting tired of doing Windows desktop development. So I moved into a role that allowed me to start doing some web development. That led to a job at Boston.com when I moved to Boston, which was and it still is the internet site for the Boston Globe. And so I was doing a lot of, and at that point, I moved completely out of the Windows world and into the Unix world. I really, around the late 90s, I discovered Unix, and I just like, wow, this is where I want to be. And I dove really head into Perl, especially. Perl was my main language for, let's say, about 15 or 16 years. So I worked at Boston.com for a couple of years, and then I happened to find a guy named Lincoln Stein. Dr. Lincoln Stein was hiring people, and he said hiring programmers and postdocs. And I didn't know what a postdoc was, but I knew that I was a programmer, and I knew that he was, especially at the time, one of the biggest names in the Perl community. He had written several books. His CGI.pm was a core module for Perl. He was deeply involved in the Mod Perl project, which is an embedded Perl interpreter in the Apache project. And so I leapt at the chance to work for him, but I didn't know what he did. He did research in biology. He essentially helped create the field of bioinformatics. He himself was an MD PhD from Johns Hopkins and Harvard, and he had gone on to teach himself programming, primarily Perl, and was very, very good at it. And so I worked for him for several years at Cold Spring Harbor Laboratory, and I worked there for 13 years before moving about 5 or 6 years ago to Tucson, where I work at the University of Arizona. And so since 2001 is really when I got into bioinformatics, and have over the years had to teach myself quite a bit of biology, in addition to also trying to teach myself quite a bit about computer science. Since being at the university, I've been able to complete my master's degree, master's of science, and that really helped me backfill a lot of information that I was lacking in, like statistics, and I got to do some formal study of computer science. And a couple of years ago, really started working more earnestly in Python because it has really taken over the space of data science. A lot of scientific computing is done now with Python. I we were My boss, Dr. Bonnie Hurwitz, and I were using Perl initially as a teaching language, mostly teaching non-computer science people how to do basic tasks in biology. And a few years ago, I said, look, we really need to turn the course over to Python. It's really just the hipper, better language, I think, for teaching. And so over the last several years, I've had the opportunity every year to help a classroom of non-computer science majors learn the basics of programming. And for the last 3 years, we've done that with Python. And I feel like it's gone really well, and I feel like I've come up with some techniques that help people learn Python better than just simply kind of hacking and eyeballing a program. I really push test-driven development. So I provide my students with tests, and I say, you need to write a program that makes these tests happy, and then you're done. And so, yeah, that's essentially how I've gotten to this point.
I love to hear that, how kind of the passion for the biology and the passion for the information technology and the programming feed off each other, and how you ultimately now, right, you kind of learned the technology originally because you kind of saw an opportunity and jumped into it and really felt pulled to the programming side of things. But then after several years of that, the biology thing just kind of is something you stumbled into. But now it seems like the technology is almost being driven more by the ability to execute on the biology side.
Yeah, so like getting into bioinformatics was so overwhelming, because Dr. Stein, he sat me down and he tried to explain these things that he wanted me to build, and he started using all these terms that I had not heard since high school, like chromosomes and genes and markers and stuff. And I was like, how am I ever going to make it in this world? The domain of the problems is so deep and complicated. It was easy enough in industry going, from a long-term health company to an energy management company to a laundry machinery company. They all have the same basic ideas of orders and customers and contacts and things like that. But then all of a sudden, to be thrown into the world of biology was truly overwhelming. And I thought, I'll just see how long this goes. I'll give it a shot. And it's been really, really difficult to learn the domain of biology. And I would say that I probably know about as much as a sophomore biology student, because I also have to keep up with the programming stuff. But the idea is that it feels like I can have a bigger impact working in this domain than just working in another industry type job. So I've stuck with it. It's meant being in academia, which I think I feel very at home in. And yeah, I really appreciate the problems that I get to work on. I feel like they're more meaningful to me.
Ultimately, if we have a good problem to solve, we can kind of get more energy, right, and passion for whatever it is that we're doing.
Yeah.
Cool.
I'm definitely the kind of person who like latches onto a puzzle and I just don't want to give up until I've solved it. And
Yeah.
so there's no lack of puzzles in this field.
Yeah. Now it's kind of making me want to investigate.
Yeah.
That's really cool. Awesome. So, one of the plans that we have for today is to actually look at some of this Python code in real time. And we have gone back and forth as we were prepping for the show on what we would look at. And this is primarily a system administration show. So our people are not biologists; they're IT people, and taking on a language is a big deal. And a lot of us are familiar with PowerShell or Bash, or even a lot of the web markup languages, or or scripting languages like JavaScript, that kind of stuff. But more and more, for whatever reason, right, Python really has taken off, and it's found its way into the IT world. And one of the reasons I've been talking with more people on Python is because of DevOps and the proliferation of Python there. So I'm really interested to see kind of in real time what we can do with some Python code, and just hear more about what it takes to get started in it, and what's possible with it.
So what I prepared, what I thought would be of interest, is to look at something you might typically write in a shell, and I chose the head program because I want to keep the cognitive load really low here. Like, we all know what head does; it shows the first few lines of a file, and I wanted to show what it would look like to write that in Bash, trying to make it look as much as possible as the actual built-in head that is, at least is on my system. And then I wanted to show how I could write that in Python, and why I thought the Python version is maybe a little easier to write, a little easier to test, a little easier to understand. And then I could show you a few iterations of the Python if we have time.
Sounds great.
So I put all this into a GitHub repo that you can find on GitHub. KY Clark is my username there, and it's called sysadmin show is the name of the repo.
That's awesome.
And so in there's let's see, I'll go up here. There are a few top level directories. One is the sh head, so I'm going to show you a bash version, and then I've got two windows open here, so I can also show you a Python version, and I'm going to show you a couple versions that are almost like line for line translations, which I think it would help you if you're making the transition from say Bash. I'm sorry, I don't know PowerShell at all. I left the Windows world probably around 1998, and I haven't touched a Windows machine since. But I do know Shell fairly well. So much in bioinformatics is built upon shell scripts, and in fact, to be a bioinformatician is to kind of a lot of times we have to install a lot of crazy packages and software. So there's definitely some sysadmin skills required. I myself had to regularly stand up web servers and install databases and compile software and just do all kind of basic sysadmin tasks. Pretty familiar with Shell, and then we'll look at the Python. So here in the sh head, one of the biggest things that I try to push over on everything is testing. I think it's one thing to write a piece of software, even a shell script. I think it's another thing to write a test for it and make sure that it actually does what it's supposed to do. And so I'm going to show you here, and I'm giving for your users how I would probably go about testing a piece of software. And so I've written the test in Python, which it might be another reason to consider picking up Python, is because I think it's fairly easy to write tests in it. And here I've included a make file, and you can just run make test here. And this is also something I teach my students, is to be able to document what they're doing with make files. So here we see that this is I'm using the PyTest module. So we can see here it's running PyTest, and it's running the test.py, and inside test.py are these functions. We can look at it. The functions that start with test underscore are the ones that will be executed. Any other, like there's a function down here that generates a random string for me, that will not be run because it doesn't start with test underscore. And the tests are run in the order that they occur in the file. So test exists first, make sure that there is this program called head.sh. So with that, let's just kind of look real quick. I'm going to assume that there's nothing in this shell script that would be surprising to your listeners. So we have a basic shell script. We have a usage statement. I'm going to take some number of lines. I'm going to default it to the value of 10. I'm going to make sure that we have some arguments. If not, we're going to bail out on the usage. In order to process command line options, I'm not sure if you've used GitOps, but it's not a lot of fun. But this is how I could, for instance, take a -n option for the number of lines, that if the user wants something other than 10. verifying that that value is a number is kind of icky. In Bash, pretty much everything is a string, and if we want, we can coerce things to behave like a number. So, for instance, I can use the LT less than operator to take that string value, and Bash will munge it into a numeric value, and then do this numeric operation on it. And then your basic kind of for loop, a couple of different loops. One is going through each iteration, through each of the positional arguments, which are file arguments. And then for each one of those, we need to read those files line by line. We have to do things like set up these counter variables for the line number and also for the file number. And if we run this, we can see how it runs. Like head, there's an inputs directory above with a few files, like it has the Gettysburg Address. And if I run that, by default, it shows me 10 lines of code. 10 lines of output. I can shorten that to 3. Oh, interesting. Oh, sorry, I have to put, sorry, I'm used to Python handling this. I can put the argument at the end. But in shell programming, the way shell handles the arguments, I have to put the options before the positional arguments. So it works with 3. I can also tell it to do all of the files in the inputs directory. And this looks just like the head. If I say head-n3 of the same, it's pretty much exactly the same output. I've got this these little headers here in place when there's multiple files. So I'll pause here for a second. I don't guess there's any surprises there with how this shell script works.
Yeah, it makes a lot of sense. And I'm not a super strong shell bash person myself, but it does make sense what's going on there. I always wondered how to do, pass a dash variable to it, like the dash n, so that you could then take it in. So it's kind of cool to see it actually in the code there.
It's not bad. Oh, and and the other things I force my students, for instance, here I'm running the program with no argument. So you see it creates a usage statement. Same for if I do -h, it's going to give me that same usage statement.
Very helpful.
And yeah, so I insist that my students create programs that are documented and tested and reproducible. And like their final project that they're turning in right now has a README file that describes what their program does, and their name and their email address needs to appear in the program. So like if there's a problem with it, somebody can contact them, right? And their program must create a usage statement like this. This is vitally important for programs that we write. So, but again, it's not a lot of fun. Like I said, if you've not used GitOps in Bash, this is really, really easy to get wrong. And there's a lot of kind of just hidden knowledge that you need to know to make that work. Like, why do I have to do shift 2 here after I get the number of lines? It really requires understanding some really esoteric stuff about Bash programming, which I don't think is really a good use of space in your brain. So
and then you're stuck on one platform.
Yes, exactly. So, it was kind of the reason why Larry Wall created Perl. He said it was easier to port. He had, what's the quote? Something about how hard it was basically to port one shell script to another. Like if you've written it in, Bourne shell, what's it like to port that to C shell? And so essentially that's why he created Perl. And I think it's the same here. If I write this in Python, then it can run on Windows. It can run on my Mac. It can run on a Linux server that I have. And then now Apple seems to have gone to, they want to use ZSH as the default shell now, which is, I don't have space in my head to learn yet another shell programming language.
Right, exactly. Okay,
so I'm going to show you how to do a simple version of this in Python. And, something I need to put, I'm going to add something to this repo. The way that I write my programs, I never start from scratch. That's one of the first things I would say. All of this program here, one of the biggest things that I push my students to learn is the arg parse module. So this is what's going to parse our command line arguments. And it also creates the usage statement for us too. So if I run this with no arguments, it's going to give me that usage. If I run it with -h, it's going to give me the longer usage. And all of this is being generated by argparse because I take a section of code to describe what the arguments are to the program. And one of the nice things about this is when I describe them, so if you're not familiar with, like how we talk about command line arguments, some are positional and some are options. And, then of course we have flags. So, for instance, the good old fashioned ls command. Ls takes no required arguments. I can give it the -l flag for the long, which is a flag. It's either present or not present, and it says I want to see the long listing. And so ls will show me this. ls-l will show me the long listing, and I can also give it a positional argument of like head, like a specifically show me just the head file. And so the head here is the positional argument. If I were to also say test.py, then there would be two positional arguments. So here, the way to define a positional argument using argparse is to just name it, like this file. But when I put a dash, or if I put any dash in front of it, it becomes some sort of an option, something I can leave off. But this is a positional argument, and it's going to be required. One of the other nice things here is I can say that the type of this argument is that it should be a file, and the R here says that it's readable. So all of a sudden, right there, argparse is doing a lot of work for me. It's very validating that all of my arguments are readable files. If I go over here and show you the head file, I'll give it some garbage, and I actually had to write the check in the head to verify that the argument that I've been given is a legitimate file. And that looks like where it is. Here we go. I have to write this inside my loop. I have to say if this is not a file, or if this is not readable, then I have to echo the error statement and then continue through this loop. Over here, I describe that any argument to my program, any positional argument, needs to be a readable file, and that's it. That's all I have to do. And then here I'm defining a number, a -n for the short flag, or --num for the long flag, which is a little harder to do also in a bash script to handle short and long flags. Not impossible. And I can say here that the type of this argument should be an int. So argparse is going to take the trouble to validate this. So let me go over, and while I have that open, show you in Python. If I try to run this program with -n, foo, it's not going to allow that. It's trying to coerce that value into an integer, and it sees that it can't. It throws the error for me, and it creates this really nice usage. So that's really great. And if addition, if I give it a valid in argument, but I give it garbage for the file, then it's going to also stop and say there's no such file directory, blah blah blah. So all of that's being handled for me right here by argparse by virtue of the fact of the way that I've described the arguments. So again, I'm not having to take on the burden of validating these myself. I'm just descriptively saying to argparse, this thing needs to be a file, this thing needs to be an integer, you handle figuring it out. There's also a way inside of argparse here to manually validate something. Like for instance, I need to make sure that that number is greater than 0. I can't show negative 2 lines from a file. So there's also this really nice way of throwing your own errors here. So if I were to run head with -n, -4, I have to give it a file. Let's give it the test file. It's going to never execute because it's going to tell me that that was an invalid value for -n. So that's the section of my code just for dealing with the command line arguments. Are there any questions on that? And does that seem like a better way of going about it than say coding through GitOps?
Yeah, I mean, right away, and I don't know how to read Python that well yet. And right away, just looking at it, it's much more plainly easy to understand what's going on here.
Yeah.
And maybe it's just my experience with other languages that's helping me out. But the bash was kind of all over the place, and it was longer. There's a lot. It took a lot more lines to do the same amount of work. So you'd have to kind of scroll through and follow that logic as it went through.
And my experience with writing Bash is that my Bash programs tend to be quite long and they just read from the top to the bottom. And it's very difficult for me to really put things into functions and to kind of containerize these things. It's very easy in Python to create a function. So I have defined this function called getArgs. And so that when I run my main function, I just call getArgs. So really, and this is something that's funny about Python. I have a very specific way that I teach my students to work using a program called NewPy that I've written. And if I'll it's on my system here in my local bin. I'm going to copy that into this directory. Oops, copy that to here, and I'll add that to the repo so that you can use it. But if I say new py, Dustin.py, then it's going to create a new file for me with all of these options already available, and kind of the whole structure of a working Python program that just works. So I can take this program and I can run it right away. It's already been chmod plus x, everything. And it shows you what I want to show you here is that the argparse can do a ton of work for you. And you really just need to learn how to describe things to it. And so here I'm showing you how to declare a positional argument, and then options H and dash help are always reserved by argparse for showing the usage, so you can't declare those. But here I'm showing you how to declare like a string argument, an integer argument with default values, like here default value is 0, a file argument that needs to be a readable file, and also a Boolean flag. And if we look at the Dustin program, then you see it's very similar to what we have here on the left on our head program. It's just I'm showing you this is what it would look like. Just go in here and modify this program to make it do what you want to do. And then down here at the bottom, you in Python, this is the Pythonic way to kind of kick off the script. A lot of programming languages will just start at the main, the main module and the main function there. Python, you kind of have to tell it, oh, we're in main, go run this function. I call it main here, but that's just a convention. You could call it start here, as long as but you're kind of responsible for kicking the program off. So that's what this couplet is doing down here. It's saying double underscore name double underscore will be set to double underscore main double underscore when the program is being run from the command line. So that's a way of knowing that, oh, we're running this right now. It's not just a module of code that's sitting on our hard drive. So when this runs, it's going to call getArgs. And what I like about compartmentalizing this is that once we've defined that in the function and we've defined what our arguments to our program should be, we don't need to think about that anymore. That unit of code has been handled, and it's being handled really, really well by argparse. So there's not much that we need to do there. Once we get to this point in our program, then that means we have the correct number and type of arguments to our program, which saves us tremendous amounts of work. In the exercises that I've written, I can show you programs where they would be 2 to 3 times longer if I had to do all that work myself. So I think that this is a crucially important thing to understand. You can really make your life a lot easier just by learning to use some of these modules that Python has to offer.
And I think you made a really good case with that, what was it, new.py?
Yeah.
Example for learning some basic programming, and even if it's not Python, even if it is PowerShell or some other kind of programming, for us IT people, there's things that we do all the time that can be automated. And a lot of us that have been in the industry for a while maybe didn't start with all of the automation. So, and we've been going about our business and our career, and we just haven't really gotten up to speed with it. And maybe even we're a little bit intimidated by it. And so it's hard to really want to open up, right, and try it out. But just seeing that one example alone, where you now have a template for a certain X amount of work was done for you in a template. And because it's software, that work is saved into the future forever, however much work that takes. And maybe it took you an hour or 2 hours to get that template set up, but now that 5 minute or 10 minute, or maybe it was an hour thing that you needed to do and maybe you do it every week or every day, is now automated and done for you. And it will give you returns on that investment over and over and over again. And not just on the
Absolutely.
investment,
Yeah.
right? Not just on the investment in writing the program, but the investment in learning how to automate, learning how to program at least a little bit, right? We don't have to become to the extent that you are in making programming our primary thing, but knowing enough about it that we can automate some of our daily tasks that are a little bit more mundane and are taking up, not only taking our time, but also taking our attention, distracting us from things that we could be focusing on, like cybersecurity is a really big thing now. And it's hard to find time to focus on that when you're doing your routine tasks.
Yeah.
So I really like
And
this
this
example.
And this is what I get excited about with teaching. Really, I primarily work with biologists. I really want to teach them how to, you know, handle their data in a way that they can get to meaning faster, rather than like trudging through these things manually. Yeah, there's I really just unfortunately just love programming. And so I think I take my students, I'm like, oh, and here's another way you can do it, and here's another way you can do it. And they're like, shut up, just show us one way and we'll be fine, you know. But yes, there's so many ways to do this, and I think it's really exciting to learn them. The other thing I was actually meant to say was I actually used as is what I do all the time. I actually wrote a Python script to help me write Bash scripts too. So I'll put that in here too. So it's called new Bash, and if I say new Bash Dustin, then we can look at the Dustin file, and it basically has that. In fact, this is how I wrote the head program earlier today. I just started with this, and I expanded from there. So if that's helpful at all, I'll also commit this to the GitHub repo.
Yeah, that's
Um,
cool.
so this version of the Python head, it's not going to pass all of the tests because I wrote this one to handle just one file. I thought it might be useful to just focus on the simple case of handling a single positional argument. So this will show you the head of just one file, and then 10 lines by default. So what I really like about argparse is the ability to set defaults, because a lot of times I would like to make a program really, really flexible, but I don't want to put the burden on the user to supply 6 or 7 options. Just give reasonable defaults for all these options and let the user override them, which is exactly the way head works. Head by default, I think, shows 5 or 10 lines. I'm not sure. And so, so for instance, if I want to run this head, and I can give it the test program, it will show me the first 10 lines. And what's fun, I guess I've come to rely on this, I can actually put options at the end because of the way argparse works. So the position, it can figure out that, oh, test.py is the positional argument, and in4 is the option there. So that works. I can also give it, oh, no, I cannot give it multiple inputs. I won't show you that yet. And I can run my test suite on this, and you'll see that it passes all the basic ideas. Like, okay, there is this. I always do this for my students. You have to first create the program that I told you to create. So they always know that they have to create that program first. The program has to create a usage statement. So if I run head-h, it gives me a usage. Let me look at the test output again. The next one is that it passes in a bad file. So for instance, if I run head with garbage, it's going to tell me, no, I can't run. That's a bad file. I pass in a bad number. So I pass in dash in foo on some kind of input, and it tells me, no, that's an invalid value. I pass in, and then I run. So that's the way I always write my tests. I basically make sure the program will die and give a useful message on all these bad cases. And then I start to give it good cases. So the default is I expect to see 10 lines of output. So if I run that on the Gettysburg Address, it'll show me the first 10 lines. And so this program passes all of those. I think it might be instructive to take a minute and look at the test side of it too, because this is actually doing a lot of things that I would think would maybe appeal to systems administrators. One is like, how do you say, like, what does a file exist? In Python, you would use the OS module. Inside of that is a submodule called path. Inside of that is a function called isFile. And so this returns true or false if a given file exists. If you wanted to execute a program and get back the return value and the standard out from that, and unfortunately, I think it combines standard out and standard error. But you can get the output from the program and the return value by using this get status output, which we get from the subprocess module. So it's really very easy to run an external process and get back what it looks like. Here I'm using, I think this reads rather well. I'm saying assert, which wants a true or false value. And if it gets false, it's going to throw an exception and blow up. So I'm saying, does the output, if you convert that to lowercase, does that start with the word usage? And so as long as that returns true, then this test passes. Here I'm using this function I wrote to create this random string, which will not be a name of a file. And so I assume I'm asserting that my program does indeed return a non-zero exit value when it's given bad input. And this is another thing that I stress to my students is understanding these things about return values and how processes talk to each other, which is something else you get from the argparse, is that if any of these conditions over here fail, like I give it a file that I give it a file argument that's not actually a file, if I give it a number that's not actually a number, then argparse is going to throw an error and it's going to exit the program with a non-zero exit value. So it behaves properly, in the system, the way we expect our systems to work. If you're not familiar with regular expressions, this is a way for me to say inside the output. So let me go over here and run the head with garbage. It creates 2 lines of output. The second line is kind of long. I kind of wish it would wrap. And I want to find this phrase inside of it. I'm looking for no such file or directory and then whatever was the garbage name that I passed in. I can do that with a regular expression. So there's a module called RE for regular expression. And I could say search through output for this string. And I'm using the F string way of describing. I think it's new to Python 3.6, but it's a lot like Perl in that, or Bash even, in that I can interpolate a variable inside of a string. So Python didn't have that until a year or so ago. And so it allows me to write this, and that looks pretty readable. Here's how I can get a random sample if I wanted to, for testing output. Here's how, when I run on Sonnet 29, I'm saying this is what I'm expecting, and so when I get the output, does it look like this? 10 lines of text. So I think it's very instructive, maybe for your listeners to look at the test as well as looking at the head to see how you might do these kind of sysadmin things. Do things like get a random int. There's a function for that. Make a random choice from some list of options. So I'm gonna stop for a second because I'm just like barreling ahead. Are there any questions on what I've showed so far?
I mean, all this is great. And to your point, this is a fantastic starting spot for anybody learning, but also specifically sysadmins, because there's so much, right, just good examples that are already laid out here that you can cherry pick and then take those into maybe part of your own program and test them out individually to see how they work and how you can use them, because these are all the kind of functions that you would want and abilities that you'd want to have when you're getting started to just see what's possible and what you can do, right? And that's kind of the why we landed on the head example, because it's such a basic need to look at a file, read some of that file, and then spit some version of it out.
Yeah, and if one of the things that I come across a lot, especially people who don't have a computer science background, is they've never heard of these things called regular expressions. So probably your listeners have, they at least know the grep program, but maybe they've never really delved deep into how to write regular expressions. They're unbelievably powerful. And so much of biology, one of the reasons why Perl was so popular in early days of genomics is that it basically, Perl basically combines shell and grep and sed and a bunch of other ideas and just kind of crams them all together. And so Perl's regular expression handling is just was fantastic. It was the best pretty much at the time. And there's a lot of that we have to do that in sysadmin kind of world too. Like I'm looking for some bit of text in some bunch of files. Sometimes grep will be just perfect tool for that. But sometimes maybe you need a little finer control and you need to jump into, say, Python and use the regular expression module for that.
And just recently, I was looking at a dump of my SIP logs. So this is the voice traffic going in and out of my building. And I was looking for a specific range of numbers. Were these making calls and were the calls successful? So I happened to be using Notepad++ at the time, and it has a fantastic integration with regular expressions. And I had to look up a lot of values because we do use them in IT, but I don't use them often enough to be really expert at them. I have to reference them all the time, and was able to narrow it down and get exactly what I wanted out of that. And I can see that being useful in a lot of different ways. Also on our spam filter for inbound messages, right? You've got a lot of different text and headers and senders and recipients. We have regular expressions on there that are looking for certain matches in certain ways to say, is this considered safe or is this dangerous?
Right. It's a fantastic field of study. It's one of my favorites. And I have several exercises that I've come up with that in fact, just today I was teaching class and pretty much sitting in the same room, also on a Zoom call. But teaching regular expressions on how to find the leading consonants from words. So some words start with, like, chair starts with CH, but a word like apple doesn't start with CH. So how could you find any leading consonants or not on a word? It's kind of a trivial example, but it allows you to really dig into how do you write a regular expression kind of step by step until you get one that works. I was going to take this example. So I have 3 solutions in here. I'm going to copy solution 2 to head and to head.py. That was solution 1 that we were looking at. And I'll run my test suite just to make sure I'm not seeing. Yeah, this one passes. This one passes now. It handles multiple files. So if we run this on all the inputs there from our inputs folder that I've also put in there, the output is pretty much identical to what the bash version does, and also to what the regular head does. So I was trying to get as close as I could to a program that actually does something somewhat useful. And I wanted to show you how I made it handle multiple files. So the first thing, the only difference in getargs is I added this. So I said that the number of arguments that this one takes is plus, which means in the meta language of argparse means 1 or more. Zero or more, we use the star or asterisk, and 0 or 1 is the question mark. So very, very flexible way. That's all I have to do now to make it handle multiple arguments. And if I go look at the help for that, it's what you would expect from a usage. It shows file and then optionally followed by more files. So that's all I had to do. I think that's extremely easy and very powerful. Otherwise, the get args section looks exactly the same. But now what has changed is this almost looks, if we go back and look at the shell version, this is starting to really look quite a bit like the shell. I have to set up. So over here in shell, one of the things that I was going to point out, I don't really know a way around this other than setting, initializing some value to 0, and then doing this pretty ugly bit here to do this numeric addition of adding 1 to fnum, because I want to keep track of which number I'm in. And over here, I can use this function called enumerate in Python. So args.file now is going to be a list of open file handles. So that's another thing that's really cool. I don't actually have to open the file now. argparse has opened it for me because it's validated that it was a readable file. And so it gives it to me as a file handle, which I call here FH. And then that's going to actually be a list of file handles. And so if I use enumerate, it will give me the index of the file handle and the file handle together. And because I don't want to start counting at 0, I'm telling it to start counting at 1. And that is just so I know the number of the file that I'm on. So that's a little bit right there. That's probably something that's probably very, very new that you've not maybe encountered before, but it's something that a higher level language like Python gives you so that you don't have to do this kind of business where you won't, because what we're trying to do over here is iterate through a list of things and keep track of which one we're on. So in Python, we get like this handy built-in function called enumerate, and it tells us what is the number of the thing that we're dealing with, and here's the thing itself too. So that's pretty handy. When we write an if statement here in Python, we don't, it's like over here, let's see, if number of files is equal to 1, greater than 1. So I can write it over here. This is the bash version of that. I can actually cram it onto one line of bash because I'm basically using a short circuit AND operator right here. But I'm saying if the number of arguments to the program is greater than 1, then I want to echo this file header that separates the output from each file. And this is how I write it in Python. You write if, and then you have your condition here, your predicate, and then you terminate that with a colon. And so all of these colons that you see here, that is telling Python that what follows is a block of code. The convention, as you probably know, is that Python uses white space to delineate code structure. So I always indent with exactly 4 spaces. That's pretty much convention in the community. There's tabs versus spaces. That's a religious war going back eons. It really just needs to be one or the other, but you can't mix them. But really, most people just go with 4 spaces. It doesn't have to be 4; it just has to be consistent. But 4 is the right number, right?
There you go.
So this all the code. So def main. All the code that belongs to def main is indented at least 4 spaces. And then when we come back flush left, we're out of def main. So I define an argument here. And then when I get into this for loop, because there's a colon here, this is indented 4 spaces. So everything until it's backdented to line up with the 4, we're still inside the for loop. So in this if statement, all the statements that belong to this block of code are indented yet another 4 spaces. There was a big rift between Python 2 and Python 3. I actually honestly came to Python about 2 years ago, and it felt to me like almost exactly the same language as Perl. It just different syntax. But the fact that it's interpreted and dynamically typed and all those things, it felt exactly the same. I just had to kind of figure out how things were done a little differently. But there was I just went ahead and started learning Python 3, and I never quite understood why there was this huge bifurcation. But one of the biggest things that was different was Python 2, you didn't have parenthesis after print. Print was a statement instead of a function or something like that. I was really, really confused on that. Anyway, just in case your listeners don't know, Python 2 has officially been terminated as it's not being supported officially as of the end of 2019. So if you're going to pick up Python, please learn Python 3. If you find code that has a print statement without the parenthesis around it, of what's being printed, then you're looking at Python 2 code. And it should probably be rewritten in Python 3 just to make it last a little longer. So this is a print function, and I'm using that f string here again because I want to interpolate this value. The file handle that I've got I can call the name attribute on it to get the name of the file. And then here, I'm also doing another enumerate. So over here in Bash, I can, this is the way I learned how to do it in Bash. I don't know if there's a better way, but I use a while read to read from a file, and then you have to, redirect from the file at the bottom of the while loop. Is that the way you do it?
I'm not that familiar with Bash.
No, it's pretty ugly. I don't think that that's in any way an elegant way to read a file line by line, but it's the way that I learned. Over here in Python, if we have a file handle, we can just do a for loop on it. So just tons of things are for loops. So Over here, we're doing a for loop over args.file, which is a list of file handles. Now we have this file handle, and if we say for a for loop on that file handle, we're going to get each line of text from that file. And again, I want to enumerate because I need to know what line number I'm on. And again, I want to start counting at 1. And that's important because I need to break out of this loop when I've reached the number of lines that I want to read. I've written this in a very particular way so that this would work on extremely large files. If you can very easily call a file handle, and then given a file handle, you can call the read method, and we'll read the entire file into memory. As you could probably guess, that would be a terrible option if you're dealing with a gigabyte size file. So this is a way of reading a file line by line, and so it will only read as many lines as it needs to before it drops off. So the way to get out of a for loop is to call break, which is exactly what you do in Bash. So over here, I'm also saying if the line number is equal to the number of lines that I'm supposed to print, break. So back and forth between Bash and Python, they're very, very similar. But I don't have to do things like this counter variable and then incrementing it like this, because I can do nice things like enumerate the line numbers and the line in this file handle. That's, to me, pretty clean code. And then down here, I'm doing the same thing as down here. I need to put an extra new line in between. I couldn't come up with a cleaner way of doing this. And so, but I don't want to do it for the last file. Anyway, I wanted to show you kind of a line by line, as close as I could, how to go from the Bash version over here to a Python version. Do you have any questions about this? And does that feel like a better solution than the Bash version?
Yeah, I like it a lot. And I mean, not just because of the solution itself, but also the fact that it's portable. Right now we can take this, and we're working with files on OSs on various disk formats, and it's going to work the same.
And line endings too, right?
Yep.
Because Windows line endings and Unix line endings, and it doesn't matter. Python's going to just see that as the line ending for the operating system that it's on.
And so as I look at this, I can't help but think about tweaking it. So if we wanted to count characters instead of lines, would that be a big change?
Oh, no, it wouldn't be. And in fact, one of the homework assignments. The assignment in the material that I teach. So this head was the homework assignment. We actually wrote WC, the word count program, in class together. And so I could point you to that as well. It's also in my GitHub repo for the Tiny Python projects. But it's not a problem. If we want to count the number of characters, it's just the length of line. The line itself is, you ask for the length of it, and that'll tell you how many characters it is, and we could just increment that up. I mean, do you want me to show you that? I could say, num chars is equal to 0, and then I could say num chars plus equal to the length of line. And then let's see, where would I print it here? I guess I'll say print length is equal to num chars.
So this is going back to more how you were doing it on the Bash side.
Yeah, and so if I want to go over here to the Python version, and I'm calling it head, and I'll just pass it the test. What am I doing? Oh, I forgot to. Okay, I'm looking at solution 2. Let me copy solution 2.
You're in the solution. Yeah.
Yeah. Let me copy that to head, and then open that as head. I was like, why didn't that work? I know it should work. There, the length of this. There are 154 characters that we printed out in that bit.
Yep.
And if I, change that to 2 lines, then it prints 47 characters.
Right, and it's not that much of a stretch to just make that value then limit the output.
Yeah. Okay, I see. I'm sorry. So you're saying print instead of number of lines, number of characters.
Right.
Oh, yeah. No, we could do that. We could do instead of this. Let me comment that out. If num, let's move this to here. If num chars is greater than or equal to, I don't know. We'll say 50. Because that could be whatever.
Oh, exactly. This is almost too easy.
I could just take out that, and it will only print 50.
Yep.
You know what? I'm just going to abuse the number of lines. I'll use the argnum so we can make it dynamic here. args.num. So whatever is that number. So if I say in 100, let's see, that's 100 or so characters. That's 10 characters.
Right.
And that's, 35 characters.
That's pretty awesome.
Yeah.
That's pretty dynamic code to be able to change on the fly that quick.
Yeah, no, it's Python is not my just favorite language, but it's the one that I probably spend the most amount of time in day to day. And it's just really a capable language. The thing that I have to caution with my students is that it's a really, really good language if you really know what you're doing. Because it does a lot of things implicitly that you might not be expecting, and that could really take you for a surprise. Once you learn them, you're like, okay, don't do that. But to me, I make the joke, it's kind of like the guy who goes to the doctor and says, Doc, it hurts when I do this. And the doctor says, don't do that. That's not a great solution for a programming language. It would be kind of nice if the compiler said, oh, hey, you're trying to add a string and an integer, and that's not going to work. You don't find that out until you do it at runtime and it blows up. And that's something that I find frustrating. But if I'm going to write a program that's 100 or 200 lines long, I'm probably going to write it in Python.
Yeah, this has been a great demo. I really appreciate you taking the time to set this all up and run us through this.
Yeah, it's a lot of fun. I really just enjoy doing stuff like this. If there was time, there's one other solution that just gets into a little bit fancier things that you could do with Python. If you're really like me, kind of into programming and into especially test-driven development, for instance, I could create a head function, and then I can create a test for that function, and I can even mock up a file handle. So this is a string that will behave in code, so I can read over it line by line. And so here I'm putting, foo, new line, bar, new line, baz. And I say, if I run head with that as a kind of file handle, give me back the first line. Is it true that that gives me back foo? And if I run that same thing with to, is it true that it gives me back foo and bar? And so, I'll leave this in the repo if anyone cares to think about writing what we call unit tests. So if you think of head as a unit, as a function, how do you write a test for that function? Here's how I would do it. I would use the PyTest module, and I would write test underscore, because that's what it needs to be called for PyTest to run it. And then I always call it the function that I'm testing. Boy, keep hitting things here. So I'm testing the head function. And so I'm calling the head function with this known output, and I'm asserting that it should be this output. And I can run that by using the PyTest module. I'm doing xv. X is to stop on the first failing test, and v is verbose. And if I run that on solution 3, it's going to run this function called test underscore head, and it's going to, these both pass, these assertions don't throw an exception, and so therefore it works. So if you care to really get into not only integration testing but also unit testing, this is something you also get from Python. It's really, I don't want to say fall down easy, but all you have to do is create a function called test underscore, and PyTest will run it for you.
So what is PyTest?
PyTest is a module. It's a really standard module for running tests, for running a whole test suite in Python. And so when I've been running make test over here, if we look at my make file, it's just running PyTest. So there's a PyTest module, and when you install it, it creates a program called PyTest that you can run. And I'm saying, please run all the things called test underscore in test.py. And the xv, again, x is to stop on the first failing test, and v is verbose, to show me as much output as possible. So when I'm running make test here, it's going through the test.py program, which I can look at here. And it's running the first test here, the first function it finds that starts with test underscore, and that's test exists. And so it runs that. And because nothing inside of this fails, it assumes that that test passed. And here the assertion that I have is that the program that I expect, which is called head.py in this directory, that exists as a file that we can see. And so that passes. So PyTest is responsible for creating all of this output and showing me the percentage of tests that pass. And, it's a really pretty cool program. Like, let me show you one that I'll, assert false here, which will obviously make it fail. And so if I run my test suite, it's going to stop at that because that fails, and because I'm asserting false. If I were to run PyTest without the XMV, it would just keep running all the tests. So, oh, that was unexpected. Actually, I would have expected that to run more tests. Run it with -v. There we go. It is running all the tests, and it's showing me that this one fails, but these other ones are passing. So PyTest is doing all of that for me. It's pretty nice.
And it doesn't know what it's looking for. You have to make assertions as to what you want it to find.
Exactly.
Can we go back really quick and talk about the make command? I'm not as familiar with that.
Oh,
what are you doing with the make command there?
Okay, make is one of my favorite programs, and in fact, I just wrote a book chapter on that too. I'd be happy to share it with you. So, make was really created. Oh boy, let me just show you real quick. Okay, see, I've got this make tutorial. If we go into this, I have never written C in my life. I just was always intimidated by it. I just avoided it. But I heard that make was used in the context of writing C code. So if we look at this, oh, not that, that's the binary. If we look at my Hello C program, it's your basic Hello World. This is, I think, the shortest program I could possibly write. And of course, it needs to be Hello World. So in order to turn this into an executable, I can run GCC on it, right?
Yep.
And if I say GCC hello, it's going to create a file called a.out, which is not actually what I want. But I can run it, and it will say hello world. That's great. But I want the file. I want this to be called. I want it to be called hello, so I can give it the -o option for the output, and I say, please compile that into hello, and now I have my hello command. So what make does is allows you to describe targets. So if I say, when I say make hello, what I want you to do is go run that command, gcc o hello hello.c. And I can define as a dependency, as a prerequisite for this target, another target, which is called clean. So if you've ever built programs, and this is like so ubiquitous in bioinformatics, I download some program that's been written in C or C++, and then I do /configured.sh and make install. A lot of times I may have to go back and reconfigure, because it couldn't find, libgd or, zlib or something like that. And I will do make clean. So usually what clean does is remove things that it made in the process, so that because make doesn't want to recreate a file that it doesn't see it needs to. If the C file, if the source file hasn't changed since the object file was created, it doesn't want to recreate the object file because that's just cycles that it's wasting. So clean is usually used to get rid of the files that you made along the way. So here I'm saying, go run clean before you run hello. Clean says rm the hello file, and then go recompile it from scratch. So what this ends up creating, as make files get more and more complicated with these dependencies, that one target can have another target as a dependency. That target can have 3 or 4 other targets as dependencies. Those targets can have other targets as dependencies. It creates this graph structure. If you're really into graphs, it's actually what we call a directed acyclic graph, because it's directed because you can go from one place to another, from one node to another. And it's acyclic because it's not allowed to have any cycles. You can't have node A go to B, go to C, go back to A. That's not allowed in a DAG. So when you run make test, like if you get some C code and you run make, and by the way, when you just say make, it's going to run the first target that's found in the make file, which is usually called all. We'll do all the steps necessary to compile the program into a binary for you. Here, my first target is called hello, so it's just going to run this. So over here, if I just simply type make, it's going to run the first target that's found in my make file, which is called test. But if I had another, one called all here, and that one just did echo, hi there. And if I say make, it'll do the first target. So I have to say make the test target, and it's going to execute the commands for that. Now, this is important for a number of reasons, one of which is just that it's so easy to create. Like if you're used to creating aliases and sticking those in your bash RC, this is a way of creating aliases, but just right here for this project. And a lot of times what I'll do is like I'll write some analysis pipeline for my boss. And it's like, run it on this, this plant data set. Now run it on this, human infant data set. Now run it on this ocean virome data set. I'll create a make file that documents the location of all the input files and all the parameters that I use to run each of those different data sets, and I'll document it in a make file. So, and if any one target needs some other thing to run before it, I'll just list that as a dependency. You're essentially creating, it's really kind of amazing. You're really programming at the level of commands here. So you can create, just if you have a lot of command line foo, and you got, you run some awk, pipe in that into sed, pipe that into cut, and do all this complicated stuff. You create this beautiful, really dense command line. Take that and stick it into a make file so you can remember what that command was. I mean, have you ever done something brilliant and then 2 hours later started scrolling up, hitting the up arrow, your cursor to find that awesome command that you
all
ran?
the time?
Then put it in a make file. And it doesn't need to become an alias in your bash RC, because it's not some global thing that you're going to use all the time. Maybe it was just some amazing, brilliant thing that you discovered for this project that you're working on. And so you stick it in a make file, and it's documented forever. It's documented, and it's also runnable. So you don't have to copy and paste it out of a README and then run it, on the command line. You just say make that command, whatever was the shortcut name you gave to it. I can't say enough about make. It's been around since 1976. It's one of the oldest programs that we have, and it's still fabulously useful.
That's really cool. I had no idea of all that history. I've definitely ran the command before, like you said, I downloaded something, I had to build it, and so I ran it without really knowing what it was doing.
Yeah, well, I will put into the README here. I'll point to this make tutorial. I have a lot more. I could easily talk for more than an hour about make. In fact, I gave this talk last week to another group. But I think it's instructive to look at. Oh no, it's under images. I think that's interesting to look at. Let me just the PDF. So I made this PDF that you can read. And one of the things that I found in reading about category theory is this really beautiful string diagram. So if you think about making a lemon meringue pie, there's a lot of individual steps that need to be done in no particular order. Like it doesn't matter if you make the crust and then make the meringue and then make the lemon filling. You certainly have to put them into the pie pan in a particular order. You don't want to put the meringue on bottom. And all of these steps need to be accomplished before you put it into the oven. So it's a really beautiful way of thinking about a lot of tasks that we do in programming and computing. And these things can be described in a program like Python with a bunch of functions, and then you define the main function runs first, and then it calls getargs, and then it uses those arguments to call the head on each one of these. That's a way of programming. Make files are also a way of programming. You're saying, well, the first thing I need to do is get rid of that file. The next thing I need to do is compile this file into this other file. And then, you go forward and you compile all your object files, and then you have a linking stage, and then you create your executable. That's what make does. But you can abuse make to do anything you want. If there's any workflow at all where one thing needs to be made from some other inputs and using some commands, you can describe that with make as a directed acyclic graph.
Yeah, and
I got to shut up because I could just keep going.
No, this is all great. And to bring it back to IT, this is the essence of the DevOps movement, right? This is the essence of automation. You're taking a series of commands that get you the same result every time, right? And some of those commands are long. Maybe there's a lot of short commands, but ultimately you're rolling this all up to make it easy to execute and make it easy to repeat. And then maybe adding some variables in there so that you can pass, right,
Yeah.
things to make
Yeah.
it a little bit more dynamic, because
Right.
you're probably not going to need to run the same exact command every time, because maybe this time you want 5 VMs spun up, right? Or this time you
Right.
want the server hard drive to be 100 gigs or 200 gigs. And so you have some variables in there that you can control those different aspects, but the core of the code becomes very easy to execute and consistent.
Yes, and you can create. Which is the one I want? Uh, you can you can create variables in makefiles as well. Just so you know. So I'll leave it to the tutorial that you can read. But to me, this gets at the heart of what I teach my students. Anything that can change about a program must be a parameter. You are not allowed to hard code anything. And when you make them into parameters and then you start accepting them as command line arguments, and this is one of the things I like about Python so much, is that the argparse module is so well written and so well done. You're creating this contract, right? That this is the way the program interacts. These are the inputs that I need in order to produce this output. And then it also gets documented in a way that you can run with -- help, and you get this usage statement. And it's like self-documenting. It's really good. You make that and you give it to your coworkers. They're going to be like, hey, nice program. I know exactly what to do. You throw in a make file that automatically runs the program with a bunch of cool options to do a bunch of different things. And now you've got this automated workflow. It makes me think of, I think, is it Joel Spolsky, who one of his kind of a smell test for a build system was like, your build system should have a single command. Like, I should just be able to say build, and it does everything necessary to make the system deploy or whatever it is. It should be completely automated. And so, combining make files, shell commands, your Python scripts, your shell scripts, I think that's what we're all trying to get to, is to make our lives easier.
Fantastic. Well, thanks a lot for this this tutorial on this. This has really been great, and I think a lot of people are going to get a lot out of this.
Oh, I hope so.
All right. Well, while we're wrapping up here, I'd like to hear what you've been working on now.
Well, so I have a book coming out that really talks about all these ideas, especially about test-driven development, but it really assumes very little knowledge, almost no knowledge of the Python language. It's probably not the beginner book for a person who's never done any programming at all, but I assume you probably know what a variable and a loop is, like a for loop. And so I really start from scratch with Python, trying to build that up and providing tests for the user so that you know when you've written the program correctly. And it would probably take you several months to work through the book. There's about 22 exercises in there. There's a lot of stuff. Pretty much every program uses argparse, accepts command line arguments. It needs to be documented. It needs to work differently under different conditions. And I stress entirely command line driven programming. I don't get into notebooks. I don't do any graphical stuff. I'm just trying to stress the fundamentals of really programming, but using the Python language to teach that. So it's called Tiny Python Projects. It's available now through Manning. It's my first book, and I'm really quite proud of it. I hope it's not my last book. I feel like I have a lot more things to talk about. So you can find me on Twitter at KY or KYCL4RK, and I'm on GitHub as KY Clark. All the code for Tiny Python projects, all the tests, all the solutions, they're all available for free at GitHub, KY Clark, tiny_Python_projects. And I've also been, I wanted to make videos for all of these chapters anyway, and then halfway through the semester, I was using the book to teach the class here at the University of Arizona, and we had to move everything online. So I have recorded now 14 chapters, which is what I've been able to get through with my class over the 16-week semester. And so for the first 14 chapters of videos are available on YouTube. My username there is also KY Clark. And I link those from the GitHub repo. So I would really like to get out this idea of test-driven development, both integration testing and unit testing. And I hope to be working on some more book projects in the future.
Cool. Well, thanks a lot. And I will put links to all the things we talked about in the show notes as well, including all the places where we can contact you. So anybody who's looking can find the links easily there.
Well, thank you so much for having me. I really enjoyed talking to you today.
Yeah, Ken, thanks for coming on. This has been great. I really Love learning about this stuff. So this is really cool.
Cool.
All right. Talk to you later.
All right. Bye.
Bye. It was really great talking with Ken. I really enjoyed hearing about all the biomedical applications for programming. I don't get into the biomedical stuff or even the medical stuff very often, but it is something that's super interesting when I do hear about it and learn about it. I don't see myself becoming a programmer at Ken's level anytime soon. It is interesting to hear and learn from people that are at this level, and I see huge benefits in just being aware of what's possible, right? So I see this kind of me wading into the deep end, kind of like up to my waist, if we were to kind of go with some sort of metaphor here, and just see what's possible with some basic examples of code. And now when a problem presents itself later on in my career, I'm going to at least know, hey, this is something that's possible with code. Maybe I don't know how to do it, but I can find the person who can, or maybe it is something simple enough that I can go out and find out how to do it and then implement it. And I really like to just get a decent amount of information of what's possible in various areas of technology, just to be well informed. So Ken has provided a ton of great resources along with this episode. So be sure to check the show notes, and we'll have links to all of them on there, including code examples, which is going to be really cool for anybody who wants to try this out in their home lab. And that's all I have for this episode. I want to hear from you. Any questions or just to say hi, you can send me emails, dustin@sysadminshow.com. You can find me on LinkedIn, and you can follow me on Twitter @sysadminshow. Until next time, I encourage you to never stop learning.